what we're doing here, 1, 5, add and subtract real numbers. Tomorrow we'll multiply and divide. And there's just a couple key aspects of these processes that I want to talk about so we're all on the same page. Again, I think we can add and subtract, but I want to talk about maybe some notation, that kind of thing. First thing up there is key vocabulary, and it's absolute value. Okay, it's one of the most confusing things for students across 9th grade all the way to 12th grade. Okay, and it shouldn't be that confusing, but a lot of times we forget what the definition of absolute value means. Therefore, then it's a confusing concept. Okay, absolute value is defined as the distance a number is from 0. A distance a number is from 0. What that means then, you think about a distance always has to be what kind of number? It always has to be positive. If I travel to, from school to Walpock, that might be like 25 miles. Okay, there's no way that I can travel that, and that 25 miles come up as a negative distance. Does that make sense? I can even drive in reverse, but it's still the fact that I've traveled backwards 25 miles. Okay? So distance is always positive. So absolute value is defined as a distance away from 0, meaning that's positive. Now, the key thing that we need to understand is that a lot of people, just because of the nature of the mathematics and the way that we've been learning this since early on in our lives, a lot of people have no problem dealing with the right-hand side of the number line. Obviously, if I give you a number 4, and I ask you how far away is it from 0, you would visualize probably what I just highlighted, right? But we need to remember that there's always a opposite side of 0. There's always a left-hand side of our number line, the negative side. So this point here and that point there are both 4 units from 0. Does that make sense? Okay. Now, the symbol that we use for absolute value are those things. Okay, and then we put whatever we are talking about inside. So if I just say, let's just put negative A in here. Okay, then that is going to become positive A. Or if I had just A in there, it's going to stay positive A. If you remember, anything inside the absolute value bars turns into a positive number, right? Okay. Now, eventually, we'll deal with solving equations with absolute value, and we'll come back to this and talk maybe a little bit differently about it. But let's say A is that number 4. Okay. If I put 4 inside my absolute value bars, I get 4 back, right? And that's talking about that number right there being 4 units from 0. 4 units from 0. Okay? This here is providing me the distance. I read this absolute value of 4 is 4 or is equal to 4, but you can also read it if it's absolute value, instead of saying the word absolute value, say its definition. The distance 4 is from 0 is 4, right? Now let's do it the other way. Let's go put negative 4 in there. Now I ask the question, what is the distance negative 4 is from 0? If I start at 0 and I walk to negative 4, how many units have you walked? 4. Okay? So in the past, maybe you were taught it's an operation that always takes a number and makes it positive. Okay?
That's how I thought it.
Huh?
That's how I thought.
I can't hear you.
That's how I thought.
Okay, and you're right. You're absolutely right. That's the procedure. But the reason for them telling you that in previous years is because we're viewing it as a distance something is from 0. Okay? And you're right, and you can approach all your math that way. Whatever's in there is going to become a positive number. But why do we do that? Because we're referring to those absolute value as a distance. So when we talk then about our operations, so I want to go do another example here real quick. Bear with me, my computer keeps freezing. Hopefully maybe this will fix itself while we do this question. Let's say I give you something like this. Let's say I give you the absolute value of 2 plus 6 minus 17. And I close it off, and I ask you to simplify that. Okay? What I want you guys to remember, to realize, is that your absolute value bars, okay, those symbols, in our order of operations inside PEMDAS, they operate the exact same way that parentheses and brackets do in regards to telling us what to do and when to do it, okay? Now, they're a little bit unique because there's an added feature that they're going to make whatever's inside them positive. What I need you guys to understand is that your parentheses are the same thing or treated the same way as our bracket, which we're going to treat the same way as our absolute value. So when I do this problem here, and I say the absolute value of 2 plus 6, that quantity, minus 17, the first thing I'm going to do is run through the order of operations. I'm going to go through PEMDAS. I'm going to look at parentheses, right? Well, if I'm making the argument that absolute value is the same thing as parentheses, I'm going to look inside those. Okay? So what that means then is I don't apply the definition of the absolute value right away. I have to condense everything on the inside down to one number first. Does that make sense? So now that I'm inside the absolute value bars, I'm looking at just the green stuff. I run through the order of operations again. And the order of operations, again, are going to tell me to focus on... Oh, I'm not going to color over the green. Okay, there we go. It's going to ask me to focus on that, right? Focus on that set of parentheses. And then can I do the order of operations again inside that set of parentheses? Okay, so I look at the parentheses of 2 plus 6, and I run through PEMDAS. There's no more parentheses inside that. There's no exponents. There's no multiply and divide. So I get to 8. So I add those together and I get 8. So now I'm going to replace the 2 plus 6 with 8. Okay, I have 8 minus 17 on the inside, right? So we're still looking at those absolute value bars because there's objects inside. There's multiple things inside as a grouping symbol. So it's going to tell you to do the order of operations with 8 minus 17. So what's that give me?
Negative 9 versus 9.
Okay. So this is going to turn into the absolute value of negative 9. And now that I've got that down to one singular object, we can now apply the definition of absolute value, and we can make that 9. So that's what that thing's going to simplify to. Okay? My fear is this, is that a lot of people in the past have looked at that initial problem and said, okay, absolute value of 2 is 2, absolute value of 6 is 6, absolute value of negative 17 is positive 17, and they rewrite it that way. Does that make sense? They just take all negatives and make them plus signs. And you can't do that until you dwindle that all the way down to just one number inside your absolute value bar. Okay? Treat your absolute value bars just like parentheses or brackets until that last step, and then you can apply the definition. Okay? There we go. All right, so two numbers that are the same distance from 0 on a number line, but in opposite directions are called what? Opposites. Okay? So we're going to identify, 3 and -3 as opposites. Okay? So two numbers that are the same distance from 0 on a number line, but lie in opposite directions are referred to as opposites. Okay? Hopefully something that we knew. A number and its opposite are called
Opposite.
I'm going to put, well, that's kind of a, maybe a rhetorical question. Doesn't make a whole lot of sense. It's already answered itself. Well, I'm going to, instead of saying a number and its opposite are called opposites, I'm going to call them additive inverses. Because they undo, when we take 3 and add to it its opposite, it gets me back to what?
The opposite.
3 plus its opposite, which would be -3, gets me back to 0. Okay? So whenever we get back to 0 through addition, we have taken a number and added to it its opposite. Okay? And that's going to be one of our key things. Okay? And I'm going off of my experience in like 8th grade, 7th grade. You guys have dealt a little bit with equations a little bit, right? So have you dealt with these things? 2x plus 3 like equals 10? Have you dealt any with that? Heads, yes, no? Okay, I've seen some heads bounce up and down. I want this plus 3 to go to 0. Well, what do I need to do with that plus 3 to make it go to 0? I need a -3. Okay? Therefore, and with equations, you guys know that we do that to both sides, right? But the logic here is that we want to use additive inverses. We want to use the opposite to get that thing to go to 0. Because 2x plus 0, then it just gives me 2x, right? So that's kind of the need for being able to talk about opposites. Okay? And the fact that we call them additive inverses. But down here, all it says is for every real number a, there is an additive inverse, the opposite of a, such that a plus the opposite of a ends up giving me 0. Okay? A plus the opposite of a. If you want to use the commutative property and take that, all they did here in this line is they take that negative a, because there's nothing inside there to do any order of operation. They get rid of the parentheses and they transition it to the front. If you want to do that, that's fine. If you want to leave it this way and just say equals 0, that's fine as well. The idea is if I have like 6 plus the opposite of 6, what's that going to give me? 0. Okay? Now, going off of what they write there in the middle, what they would have done there is they would have taken the 6 plus the opposite of 6, and they said, oh, you're going to rewrite that as -6. You're going to move this out in front using the commutative property and add 6 to it. That still give me 0. Okay? The way I was taught, and this is just the way that I'm going to continue to do things, is that whenever I see a plus, that's terrible. Won't let me undo it. There you go. If I see a, still getting used to, I went like 9 years using the same programs over and over and over again. Now I'm something different. So still getting used to it. But if I see a plus, a minus, plus a minus, or plus a negative, which one of those supersedes or overrides the other one? Is the plus override the negative, or does the negative override the plus?
Negative override the plus.
Negative, in this case, when we're adding, the negative overrides the positive. So what I'm going to do, whenever I see this, 6 plus the opposite, I'm going to write it this way, 6 minus 6. The negative overrides the positive. Now, the reason the negative overrides the positive is this statement right here. Okay? And if we wanted to, and it says key concept, subtracting real numbers, I could wipe that away and just say definition of subtraction. This is the definition of subtraction right here. It says to subtract a real number, you add its opposite. To subtract, you add its opposite. So subtraction is defined as adding something's opposite. Have you ever heard that phrase before? Subtraction is adding the opposite. Okay? So if I have a number, now they write it as A minus B is equal to A plus the opposite B, because this is subtraction, right? So reading this left to right. To subtract, all you're really doing is adding that object's opposite. Okay? A minus B is adding B's opposite to A. If you ever see something like, 2 plus negative 8, okay? Well, adding its opposite is the same thing. That's what this says, right? Adding 8's opposite. You can rewrite that as 2 minus 8. And a lot of people are going to maybe feel more comfortable seeing it that way, right? Does that make sense? Okay, but subtraction. So here's the thing that I think is interesting with math. We've talked about multiplying, adding, subtracting, and dividing, right? You guys remember saying that multiplication is the same thing as repetitive addition? So multiplication eventually comes back to addition, right? Or multiplication exists because of addition. You guys remember talking about division being repetitive subtraction? Okay, then we talked about that early on, maybe the first, second day. So division is defined through subtraction. But what did we just figure out? That subtraction is the same thing as adding the opposite, right? So all of our math is predicated off those 4 operations. All of our math goes through adding, subtracting, multiplying, and dividing. But multiplying, subtraction, and division all work their way back to addition, right? So all of our math is just adding. Everything that we do is just adding. Okay? However, we learn shortcuts and procedures and processes that allow us to do that adding much faster. So multiplication allows us to add much faster, right? The distributive property allows us to, it's multiplication that allows us to add quantities much faster. Okay? So these more complex procedures that we learn are to do things faster, be more efficient. But it all comes back to addition. Okay? Questions on that? Can we add the opposite? Can we do that stuff? All right. Now, I want to put down through our through our notes. I want to incorporate some story problems. When you guys take the end of course exam in May, I think it's April 29th, something like that. It's going to be about 40 questions, and a majority of them are going to be story problems, where you are trying. Now, they might not be extremely difficult story problems, but they don't just give you like -1 plus -4 plus -8. They're going to give you some scenario where you can pull off the -1, where you can figure out where the -4 comes from, and then the -8. Does that make sense? So kind of looking at the scuba diving question, it says a reef explorer dives 25 feet to photograph brain coral and then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. Then the diver rises 29 feet to see an underwater cavern. What is the location of the cavern in relation to sea level? So what they're doing here, what they're asking you is to just develop a number line. Okay? And then from that number line, go through this process and see if you can write down an expression of addition and subtraction. So, first thing is, you guys are accustomed to number lines being left and right, correct? We're accustomed to that number line, we're accustomed to that number line, and we can do that here. But I would argue that maybe it makes more sense to make our number line in this question to go up and down. Because he's diving, right? He's diving and rising. So I think that added idea makes sense to make an up and down or vertical number line. What number should be attached to sea level? 0. All right, so the first thing says he goes, so the reef explorer dives 25 feet. So if I'm at 0 and I dive 25 feet, that means I'm going down, right? Okay? So what sign should I put with 25? Negative. At negative 25. Okay? He gets down to negative 25 and it says he then rises 16. I'm going to rise 16. So what sign should go with 16? Positive. Okay. And then the diver travels over a ridge, diving 47 more feet. Minus. And then he rises at the end 29, right? Go back up. So rising 29 should be that, correct? I think that's the way most people would write that. If you wanted to, you could write this. You might see it from time to time in your explanations or notes or stuff like that. These all say the same thing. I put addition in between all, but wherever it was a negative number, I put it. So that subtraction right there, 16 minus 47, is adding the opposite, right? There might be times where it makes sense to write it here as I did in the red, and then there will be times where maybe it makes sense to add it like this. I'm going to go back up. We'll leave it that way. We can talk about it in red. Let's say that I've got, I owe somebody, let's say I owe Travis 25 bucks. Okay? Going off order of operations, I need to do those two things first, right? So I owe him $25, okay? But then I add in 16. So I'm 25 in the hole, but now I've added 16 to that. Okay, positive, so I moved to the right on the number line, in this case up on the number line. How much do I owe him now if I paid him 16 bucks for the 25 that I owe? I'd be at negative 9 now, right? I owe him $9. So I owed him 25. I gave him 16. Now I only owe him 9. So I'm $9 in the hole. Now I'm going to continue with that. So now I owe him $9. He's a nice guy. I borrow 47 more from him. Now if I owe him 9 and I borrow 47, how much do I owe him total? What's 9 plus 47? 56. But I owe that to him, right? Very negative. And I'm going to add then 29. So I'm $56 in the hole. Okay? That's what I owe him. I get paid. I give him $29 of what I got paid. Now how much do I owe him? Negative 27. So that's the current debt of that person. Now, I understand that you can grab a calculator. Many of you are going to do this. And you're going to type in negative 25 plus 16 minus 47 plus 29, hit enter, gives you negative 27, you write it down, right? But if I do that, if I continue to do that, think about this. If I injure my leg and I get crutches, and I keep using those crutches, and I never stop using those crutches, and my leg is going to heal in a manner in which I can put those crutches down and walk on my own 2 feet someday? Or am I going to limp? I'm going to limp, right? I'm going to have a deformity in my leg because I didn't heal right, because I always use my crutches. So if I struggle at adding, subtracting, multiplying, dividing, okay, and all the other processes that we go through, and I continue to rely on my calculator, my crutch, will I ever be able to do those things on my own at some point? Okay? So we want to avoid the calculator. Okay? I don't want you to that be the first thing you grab to get your answers. Okay? Try to do some of the stuff in your head. Try to write down the procedures that we just went through, like combining the first 2 terms and rewriting that, then combining the next 2 terms and rewriting that. Get used to that, all right? Because your calculator does not have A, B, C, X, and that kind of stuff on it, which is what we're getting to. We're going to get to working with some variables. And if you have focused only on using your calculator to understand these properties that allow us to add, subtract, multiply, divide, our associative community, that kind of stuff, our order of operations, then when we get to using variables, your calculator is going to fail you. Does that make sense? Okay? It'd be like using crutches for a brain injury. You would not do that, right? It'd be a tool that does not help a brain injury. So at that point when we're in algebra and we're using variables, your calculator is a crutch or a tool that isn't useful in that situation very often. Okay? Now, I want you to use it as a tool. I want you to do it by hand. I want you to do it using mental math, and then grab your calculator and check it. Okay? But I don't want you to type in what it gives you and hit enter and get an answer. So to alleviate that, to make sure that we're doing those things, your next quiz, which will probably be later this week, there's no calculators on it. Okay? There'll be multiplication, division, that kind of stuff, but I will make sure that the numbers are things that we can do in our head. So I won't ask you to multiply like 16 times 29, okay? I'll keep the numbers relatively small, but plan accordingly as you're doing your homework this week. He said we'll have a quiz where I can't have a calculator, so I should probably do my homework by limiting myself to my calculator. Does that make sense? Okay. Homework assignment on Math Excel. Shouldn't take you very long, okay? We'll talk about those tomorrow. Do multiplication, division. Key thing with that stuff is just the number of signs that we have, negative, and then we'll continue to work through this stuff.
Is it 25 questions?
It is 25 questions, but it should not take you 15 minutes.